Hey, what's up, everybody? In this lesson, we'll be covering the Hackerrank Easy Algorithm Drawing Book. This question is a little complicated, but not too difficult. There's just some logic that might get your brain crisscrossed. But yeah, let's dive into it. First things first, as always, let's understand what we are given and what we're looking for. So essentially, we are provided some information about a book. We know that page one will always start on the right side of the book, and we are provided the number of pages in the book as well as the page that we're searching for or trying to get to. So in this example, 5 is the length of the book. So here we have it, 5 lands on the right side of this book right here. And we would, of course, start from 1, and we're trying to get to page 3. And really, what it's asking us to do is to compare how many pages you'd have to turn from the start as well as from the finish, and basically see if you should open the book from the back or open the book from the front in order to turn the least number of pages. Now, where this gets complicated is really just that there's multiple conditions. So we know that if a book starts on page 1 and it's on the right side, it's always going to start on page 1 on the right side. So that's one simple condition. But if you were to start from the back, you see that we could have two scenarios. You could start from page 5 if page 5 is n, or sorry, if n is 5, you would start from page 5, which starts on the right of the book. But if this book only had 4 pages, it would still be set up like this, but you'd start from page 4. So because of that conditionality, the logic starts to get a little bit confusing. And I'm sure if you've done this question before, you've typed in many different conditional statements in order to get it right. But yeah, so let's head over to Replit and start to write our code. So I think the best way to do this is to find how many pages you'd have to turn from the start, add that to an array, and then find how many pages you have to turn from the back, add that to an array, and then find the minimum number of that array and return that. So let's get started and create a variable that is an empty array, and let's call it turns. And then, as I said, let's first start from the front. Replit is such a funky format versus Hackerrank and VS Code. It gets annoying. But anyway, so yeah, let's start from the start of the book, and let's create a variable called fromStart. And let's set fromStart equal to p minus 1. So p is the page that we're trying to get to. We've got it set up to the Hackerrank example up here. P is equal to 2. So let's set fromStart equal to p minus 1. So let's think of some scenarios for that and what that could be. So if fromStart equals 0. What does that mean? That means that p, the page we're trying to get to, is equal to 1. So if you're trying to get to page 1 and you're starting on page 1, well, guess what? Turns dot append, sorry, typo, append 0. You don't have to turn the page. Congratulations, you'll append 0 to your turns array. But what other scenarios do we have? So let's go to page 4 from page 1. What is 4 minus 1? That's 3. How many pages would you turn to get to page 4? Well, you'd actually have to turn 2 pages. So a good way to think of that would be to say, hey, let's actually turn to the page that has page 5 on it. Because 5 minus 1 is 4. You can go ahead and divide 4 by 2 and get the number of pages you've got to turn. What if you wanted to turn to page 3. 3 minus 1 is 2. Divide 2 by 2, you get 1. So basically, if we're dealing with a number that is divisible by 2, an even number, you want to add 1 to it and treat it as if it's the page to the right of it. So instead of considering page 3, we're going to actually consider page 4 to do our math. Okay, so yeah, that leads us to two other conditional statements. So if from start modulo 2, this would mean that there's an even number of pages between page 1 and the page we're trying to turn to. If from start modulo 2 equals 0, we will turns.append from start divided by 2. And then what's our other statement? If from start modulo 2 bang equals 0, turns dot append, and what's going to be different here? We're going to first take from start and add 1 to it to treat it as if it's the page to the right of it. Let's get our underscore in there. And then that number we'll divide by 2. Underscore is missing there as well. You know what? I should have just named it a different variable. I've been doing this all day, but I guess we'll just soldier on at this point. Okay, so there are all of our conditional statements for the from start, and now we want to consider the from end side of things. And how would we write from end? Well, because we know that the end of the book will always be a higher number than the page that we're searching for, or it could be equal to it. But that means we would have to subtract p from n. And then, as I mentioned earlier, there are two scenarios where we could wind up with some different kind of maths. We could finish the book on the left page. For example, an even number, page 8, would end on the left page, or we could finish a book on an odd number on the right page. And you'll see how this plays out as we work through the code. So let's start out with just because I like the equals always first. Sorry, not if n. If from end modulo 2 equals 0, that means that the book is ending on an even page. So if a book ends on an easy page, we've got a couple different scenarios. Let's say that n and p are equal. Book ends on page 8, and the page we're looking for is page 8. Great. If from end is less than 1, which in this case could only be 0. We can just write it like that. If it's less than 1, then great. We could do, as we did earlier, turns.append 0. You don't have to turn the page. You're already on it. Okay, what are our other scenarios? If from end is equal to 1, is that what we want here? Yeah, if it's equal to 1, what does that mean? So say we've got page 8 as the end of the book, page 7 is the page we're looking for. We can go ahead and just turn the page once. And then our last scenario, I don't know why I'm writing ifs, I should be writing elifs. Elif from end is greater than 1. what can we do here? So if it's greater than 1, we basically wind up in similar scenarios to what we wrote up here for our from start. So if from end modulo 2 equals 0, this means they are an even number of pages away from each other, we can just go ahead, divide by 2, and that's our number of turns. Turns.append from end over 2. And if from end modulo 2 bang equals 0, if there's an odd number of pages between P and N, what does that mean? Well, we actually want to consider from end, we want to consider the page to the left of it. Make it an even number that we can then divide by 2. So page to the left of it would be subtracting 1 from our from end variable. So that means turns dot append, and in parentheses we'll take from end, subtract 1 from it, and then outside of those parentheses divide by 2. Okay, so that should wrap up all of our scenarios. Let me make sure. Yeah, I mean, you could, oh, that's why one error. You want to write else here, not if. Okay. There are our scenarios for the even paged book from the end. And then, of course, we'll have to go back down to this level. You could write else here. You could write elif. We're just going to write elif. If and, why do I keep writing n? If from end modulo 2. Oh, you know what? I'm sorry. We do want n there, because n is the number of pages in the book. So if the number of pages of the book is even, we'll follow this flow. If the number of pages in the book is not even, we will follow this next flow. Sorry about that. Okay. Like I said, this is kind of a long problem, really just because of the conditionality, but it's not too complicated. So you've got ifs and elifs all over the place. So in the scenario that the book is an odd numbered book, that means it ends on the page to the right. So our first condition, if from end is less than or equal to 1, because think about that. Say the book now has 9 pages. That means if P is equal to 8 or 9, you don't have to turn the page. So if from end is less than or equal to 1, we can turns.append 0. So very similar to our conditionality up here, but not quite the same. We've got less than or equal to 1 as opposed to just less than 1. All right, so what's our next condition? If from end is greater than 1. So that means we're going to have to turn the page, but how many times will we have to turn the page? Well, that depends. If from end modulo 2, if we've got an even number of pages separating, really what we can do is this will be exactly the same. Our first condition differs, but these next conditions are identical. So we can just go ahead over and copy and paste these last two conditions. Actually, you could even include this line if you wanted to. It's all the same. But so that should be it. That should satisfy all of our conditions. But of course, as usual, we want to test to see what we're getting. So let's first print turns, see what our array looks like. In the example of 6 and 2, we get turn the page once or turn the page twice. But that's not what we're looking for, right? We want to print the min of our array turns. The min is 1. And look at that. We've actually got a float. This question is asking for an integer. So we will print int min turns. Let's check that out. Make sure it's giving us what we want. Great. And then, of course, because it's Hackerrank and it wants us to, I'm typing hacker. Because it's Hackerrank and it always wants us to return our value, we can print int min turns. So let's go ahead and copy and paste this all over to our, you know what, I'm actually going to copy it right from my VS Code example that I've got off page, so I don't have to go in and correct all the formatting. All the formatting lines up, but I promise you this is identical to what we just wrote. So let's go ahead and run the code. And wait. Okay, so our two first examples check out. Let's submit the code, test it against all of Hackerrank's test cases. And voila, that's it. All right, thank you so much for watching. I hope you enjoyed. If you have any questions, feel free to pop them below. If you have a better solution, if you could consolidate this into less lines of code, that would be awesome. Please suggest that down below as well. If you enjoyed, please go ahead and hit the like button, hit subscribe. I'll be posting these frequently, and thank you for watching.